Okay, so note down a deflection of helical spring of circular wire. Deflection of helical spring of circular wire or circular cross section. So let us consider again an helical spring. Okay, so which is an n number of turns, which is the mean diameter d and wire diameter as a small d. So now this is what a mean diameter, and it has an wire diameter as a small d. Okay, wire diameter as a small d. Okay, now so here you are going to get a two type of deflections here. One is axial deflection along with the angular deflection. Okay, axial deflection along with the angular deflection. Okay, so angular deflection will take place because if you consider the one quadrant turn here. Okay, so what happens? So if you consider this has been fixed. Okay, so if you apply the load along with the axial deflection, now let us take, I'll go for this is what a top view. Now I'll go for a front view here. Okay, I'll go for a front view. Now along with twisting movement, it is going to deflect some angle here. Okay, it is going to deflect some angle. So here also it is going to deflect some axial distance here. It is going to deflect some axial distance. Okay, so now you need to find out both, and you need to go for equating those two things, and you are going to get the equation for a deflection. Okay, now as I said, let us consider. Okay, let us consider. Okay, so total active length of the wire. Total active length of wire. Okay, now for analysis purpose, we are considering. So we are going to unwound all these spring in the form of a straight bar, in the form of a straight shaft, or in the form of a straight wire. Right. So now let us take this as L equal to active length of wire L equal to length of one coil into number of active coils. Number of active coils. Right. So now what is the length of one coil? Now if you consider this only one coil, let us take now you have one coil here. Okay, so what is the length of this one coil? What is the length of this one coil? How are you going to get the length? Now you need to unwound this one. Okay, you need to unwound this coil and form this as an circular straight bar. Okay, so now what is the equation here? ಏನ್ ಬರುತ್ತಾ ಅನ್ವೌಂಡ್ ಮಾಡಿದ್ರೆ ಅದರ ಲೆಂತ್
The circumference of the coil.
right, so circumference is what pi d into I. Okay, 5d into r. Okay? So now this is what total active length of the wire. Now let us consider theta equal to angular deflection of wire. Angular deflection of the wire when acted upon by torque T. Acted upon by a torque T. Okay? ಜಲ್ದಿ ಜಾಯ್ನ್ ಆಗ್ಬೇಕ್ರು ಯಾರವರು ಈಗ ಬಂದು ಜಾಯ್ನ್ ಆಗತ್ತಿರಲ್ಲ ಏ ತೋಬಂಗ್ ದಾರಂಗ್ your class timing is entirely different. Okay, so you don't join this class. You join class from 4 to 5 evening. Are you able to hear?
Okay, sir. Okay, sir. Okay, sir. 4 to 5, sir.
Okay. Now, when we get angular deflection, you can just recall from strength of material derivations what you have done. Okay. So now, if you fix here, okay, if you apply the torque at this end, so if you consider a layer, okay, you consider a layer here, okay, so it is going to make a deflection here, okay, from O to O dash. Okay. O to O dash is the what? Angular deflection. That is what at theta. So now this is what angular deflection here. You may some get value of gamma or other things. Then you are going to equate both and you are going to find out the equations. Okay. So now let it be. Now angular deflection of the wire when acted upon by torque T. Okay. So now, so now, therefore, the axial deflection, okay, of the spring, okay. So let us take this as a y. This is equal to theta into d by 2. As I said, if you consider this as a y, okay, and this is the theta, okay. So now we can go for using trigonometric relations. You can find out y equal to d by 2 into theta, right? Now, you have a relation here, okay. So the torsional stress relation, okay, in terms of the angular deflection, okay. So what is the torsional stress relation? Torsional shear stress relation. So T by J equal to tau by R equal to G theta by L, right? G theta by L. Okay. So now in this case, the R is what? Capital D by 2. Okay. R is capital D by 2. Now you need to consider this distance, right? Now you rewrite for theta here. Now you can neglect this term because you are calculating the angular deflection based on the application of torque. Okay, let us neglect this center portion. Now you will note down g theta by L equal to T by J. Now write it for theta. So what will get? Uh, T into L divided by G into J. Okay, G into J. Right? J is what? Polar moment of inertia of circular cross section. Okay, let us substitute J equal to polar moment of inertia of circular cross section. Okay, so J equal to what? Pi d to power of 4 divided by 32. Okay, pi d to power of 4 divided by 32. So G is what? Modulus of rigidity. G equal to modulus of rigidity. Right? So T already we calculated last derivation, there is f into d by 2. F into d by 2. Now the active length of wire already have calculated earlier, so L equal to pi di. Now let us substitute all these equations in theta here. Okay. So now theta equal to what? F into d by 2. It related to value of t. Pi di. It is related to L, and now you simplify what you are going to get. So now this is equal to what? How much you'll get? Whether you are going to get F pi d square I divided by 2 whole divided by g pi d to power of 4 divided by 32. If you further cancel this one, now this is what 16. Okay, so now whether pi get cancels here. Okay, whether this is equal to 16 fd square into I divided by g d to power of 4. You just cross multiply and give the value. Is it right equation? Hello. Am I audible or not?
Audible, sir.
So whether
Audible.
this equation is
Yes,
correct?
sir.
Okay, now substitute this value of theta in axial deflection equation. Okay, so substitute. So this value of theta in equation. Okay, so that was what equation here? Where you got in this equation, right? Take this as a 2. Okay, axial deflection equation y equal to theta into d by 2. Okay, so now theta value is 16 fd square I divided by gd to power of 4 into d by 2. Okay, so now y equal to 8 fd cube, okay, into I divided by gd to power of 4, gd to power of 4. So now this is what equation for deflection. Okay? Deflection for a deflection, or you can write this equation as 8fc cube into I divided by gd. So where c equal to capital D by small d. Okay, where c equal to capital D by small d. You just check out equation number from data and book. I hope you you have in data and book equation.
11.5 years.
Okay, so equation number 11.5a, right? So you can find out a deflection by using this relation. Okay. So next you can rewrite this equation to calculate the number of turns. You just refer equation number 11.6 here. Okay. You refer equation number 11.6. You can use this equation to rewrite for number of turns. Okay. Okay. So you just note down procedure. Just note down procedure of helical spring. Okay. Note down design procedure of helical springs. The first step, design of wire diameter or shear stress. Shear stress. Okay. Second, mean coil diameter. Now in this you can calculate small d or tau. Okay. So next is mean coil diameter. So third one, so deflection or number of active coils. You can calculate small y or you can calculate small I. Okay. Next, the free length of spring. This is what L naught. Next, you need to calculate pitch. Okay. So this is what a small p. Next, spring rate or spring stiffness. Next, length of wire required to manufacture. Required to manufacture. Okay. So you need to follow these 7 steps. You need to follow these 7 steps. Okay. Hey, you have any doubts over these derivations? You have any doubts? Hello?
No, sir.